There is something your body has been waiting to do all day. Not sleep. Exactly. Something quieter than that. Something that happens in the space just before sleep, when the grip of the day finally loosens, and everything you have been holding begins, slowly, to release. Tonight, you will discover what that release actually does to your brain, your cells, your nervous system, and understand, perhaps for the first time, why letting go is not weakness. It is one of the most intelligent things a human body knows how to do. Welcome to Get Sleepy Science. Wherever you are right now, perhaps lying in a familiar darkness, or feeling the weight of a long day still resting on your chest, allow yourself this moment. You do not need to solve anything tonight. We will trace 100 psychology facts about letting go. From the first millisecond your nervous system shifts out of alert, to the deep biological repair that only begins when resistance fades, to the quiet truth that your body has always known how to come home to itself. These calm explorations of the mind and body create a gathering place for tired souls who are learning, slowly, that rest is not something you earn. A gentle like, subscribe, or quiet share helps others find their way here. People who need this exact kind of stillness tonight. It brings us closer to protecting this space, one sleepy soul at a time. It means everything to us that you are here. Let yourself settle completely now. Feel your jaw unclench, your shoulders drop away from your ears. You do not need to hold on to any of what comes next. Just let these words drift past you like slow water. Sense that warm, gentle heaviness beginning to spread. Like your body is finally remembering that it does not need to brace for anything. There is nothing to protect against tonight. You are already safe. Close your eyes and breathe deeply. You are floating where the nervous system finally falls, quiet and still. Let your mind dissolve with the soft release of everything held. And now we begin. Letting go is not a feeling. It is a physiological event. When the human nervous system shifts from a state of holding, vigilance, tension, anticipation, into a state of release, measurable changes occur within seconds across the brain, the heart, the muscles, and the digestive system simultaneously. Researchers studying the autonomic nervous system have observed that what we experience emotionally as letting go maps almost exactly onto what the body calls parasympathetic activation. The two are not metaphors for each other. They are the same event, described from two different directions. When you feel yourself finally exhaling, truly exhaling, something real and biological is happening inside you. The autonomic nervous system has two primary modes. The sympathetic branch governs activation, the ancient alertness that scans for anything unfamiliar, tightens the muscles, sharpens the senses, and holds the body in a constant state of readiness. The parasympathetic branch governs restoration, the quieter, older state in which digestion resumes. The heart steadies, and tissues begin the slow, careful work of repair. Most people spend far too many hours in the first mode. The body was not designed to stay there. Letting go, in biological terms, is the act of crossing from one branch to the other. The vagus nerve is the longest nerve in the human body. It branches through the chest and into the abdomen, connecting with the heart, the lungs, the stomach, and the intestines. Remarkably, most of the information flowing through the vagus nerve travels upward, from body to brain, carrying the constant report of what is happening inside. When you breathe slowly and allow your muscles to soften, you change what that report says. The body sends a different message, and the brain, receiving it, responds in kind. Letting go is not passive. It is an act of transmission, a message sent upward through the longest channel in the body. Heart rate variability, the slight, natural variation in the time between heartbeats, is one of the most closely watched indicators of nervous system health. A high heart rate variability suggests a body that can adapt fluidly between states of alertness and rest. A low heart rate variability often accompanies chronic stress, poor sleep, and difficulty releasing tension. Research published in leading psychophysiology journals has consistently shown that practices associated with letting go, slow breathing, progressive muscle relaxation, mindfulness, directly improve heart rate variability within minutes. The heart literally becomes more flexible when you allow yourself to release. Cortisol is the hormone most associated with the stress response. It prepares the body for action, raising blood sugar, sharpening focus, tightening the cardiovascular system. It is useful, necessary, and deeply ancient. But cortisol was designed to rise and fall in short cycles, not to stay elevated across entire days and nights. When we hold on to worry, to plans, to unfinished emotional business, cortisol levels remain elevated long after the event that triggered them has passed. The simple act of letting the body relax begins to lower cortisol, not through effort, through the absence of effort. The amygdala is a small, almond-shaped structure deep in the brain's temporal lobe, and it is one of the most studied regions in all of neuroscience. It functions as the brain's alert center, quietly monitoring incoming sensory information, weighing what feels familiar against what feels unfamiliar, and responding when it senses something unresolved. It is ancient and tireless, and it means well. It is simply trying to keep you safe. What recent neuroimaging research has shown is that the amygdala does not easily distinguish between real concerns and imagined ones. A worry about tomorrow activates nearly the same neural response as something present and immediate. Letting go, in part, is offering the amygdala the evidence it needs to stand down. The prefrontal cortex, the large, folded region at the very front of the brain, is responsible for reasoning, planning, emotional regulation, and what researchers call top-down guidance of the amygdala's alert signals. When we are rested and calm, the prefrontal cortex can gently moderate those signals. But when we are exhausted, chronically tense, or simply unable to release the accumulated weight of the day, the prefrontal cortex loses some of that steadying influence. The biology of not being able to let go is, in part, a story of two brain regions that have lost their usual balance. And sleep is what restores it. Muscle tension is one of the body's most habitual forms of holding on. Research in psychophysiology has found that people experiencing chronic psychological stress carry significantly elevated baseline muscle tension, particularly in the neck, jaw, shoulders, and lower back, even when they believe they are relaxed. This is sometimes called residual tension, and it represents the body's best guess that it may still need to act. The muscles stay slightly contracted, ready, letting go, on a purely physical level. often requires deliberately inviting these muscles to release, because the body will not always do it automatically. The jaw holds a remarkable amount of accumulated tension. Many people hold tension there throughout the day without ever noticing it is present. A quiet habit, a small and continuous grip on something the body decided long ago it needed to hold. When you gently allow the jaw to soften now, letting the teeth part slightly, letting the lower face go loose, something in the nervous system receives the message. The whole body is listening to what the jaw does. Researchers studying sleep bruxism, the habit of grinding teeth during sleep, have found strong correlations with daytime psychological tension. The jaw and the emotional state are more closely linked than most people realize. When letting go begins, when cortisol starts to fall, when the breath deepens, when the muscles finally soften, the body clears a path for the signals that sleep requires to be heard. This is one of the most underappreciated aspects of releasing the day's tension. It does not merely feel better. It literally removes the neurochemical interference that was preventing the body's natural sleep drive from reaching consciousness. Letting go is not the consequence of sleep beginning. It is often what allows sleep to begin. The body has been ready. The release is what opens the door. The brain has a state it returns to whenever external demands fall away, a network of regions that activates during rest, self-reflection, and the quiet integration of experience. Neuroscientists call this the default mode network, and it was once assumed to represent simple idleness. Subsequent research overturned that assumption entirely. The default mode network is now understood to be one of the brain's most metabolically active states, involved in self-reflection, memory consolidation, perspective-taking, and the weaving of emotional experience into coherent meaning. It is, in a meaningful sense, what the brain chooses to do when the pressure to perform finally releases. Rest is not emptiness. That, at least, is one way to understand it. Sleep pressure, the biological drive to sleep, builds throughout every waking hour through the gradual accumulation of adenosine, a byproduct of neural activity. By the time a full day has passed, adenosine has accumulated in the spaces between brain cells, binding to receptors that dampen alertness and generate the unmistakable pull toward rest. What is less often appreciated is how letting go of the day's psychological tension allows this signal to be felt. Elevated stress hormones can mask the adenosine signal, the body's own fatigue message drowned out by the noise of unresolved holding. When that noise quiets, the drive toward sleep rises naturally, like something that was always there beneath the surface. Adenosine is sometimes described as the brain's gentle fatigue signal, not a command, but an invitation. Every hour of waking, it accumulates quietly and steadily, softening alertness, drawing the body toward rest. Caffeine works by temporarily blocking adenosine receptors, not by providing energy, but by preventing the brain from hearing its own tiredness. When letting go removes the interference of chronic tension and stress arousal, adenosine is allowed to do its work unimpeded. The sensation of sleepiness arrives naturally, without force. Sleep is already waiting beneath the surface of wakefulness. Releasing the day's grip is how we stop drowning it out. Interoception is the brain's ability to sense the internal state of the body, to perceive heartbeat, breath, hunger, tension, temperature. and a dozen other signals arising from within. Research into interoceptive accuracy has found that people with better awareness of their own internal signals show greater emotional regulation, greater resilience under stress, and, notably, greater ability to release tension after difficult experiences. The body is always sending information. Letting go may partly involve simply learning to receive it, to trust the signals that say the day is done, the work is finished, and it is safe to come back inside. The glymphatic system is one of the most significant discoveries in neuroscience in the past decade. First described in detail in 2012 by Maiken Nedergaard and colleagues at the University of Rochester. It is a network of channels surrounding the brain's blood vessels through which cerebrospinal fluid flows, clearing metabolic waste products, including proteins associated with neurodegenerative processes, from the brain during sleep. Studies in animal models suggested the glymphatic system may be dramatically more active during sleep than during waking, with some estimates suggesting a nearly tenfold increase. Human neuroimaging research has since confirmed that sleep substantially enhances cerebrospinal fluid flow and metabolic clearance. Though the precise magnitude in humans continues to be studied, the direction is clear. The brain cleans itself most thoroughly when the body has let go of wakefulness. Brain cells share space with a vast population of supporting cells called glia. Among these, star-shaped cells called astrocytes appear to play an active role in facilitating the brain's nightly cleaning. Research has suggested that astrocytes may shrink slightly during sleep, widening the spaces between cells and allowing cerebrospinal fluid to move more freely through the glymphatic channels. This physical reorganization of brain architecture, this subtle opening, happens in the context of sleep and deep rest. It is, in its quiet way, a structural expression of letting go, the brain creating space it was not willing to create while the day's demands were still present. Breath is perhaps the most direct voluntary bridge between the conscious mind and the autonomic nervous system. Most of the body's functions, heart rate, digestion, immune response, cannot be consciously directed, but breath exists at the boundary. You can breathe unconsciously, and the body will manage it. Or you can breathe deliberately, and in doing so, send deliberate signals through the vagus nerve to the entire system below. Slow exhalation, in particular, shifts the body toward parasympathetic dominance. The exhale is, biologically, the moment of letting go. Every slow breath out is a small rehearsal for the larger release. The ratio of inhalation to exhalation matters more than most people realize. A breathing pattern in which the exhalation is longer than the inhalation, breathing in for 4 counts, out for 6 or 8, has been consistently shown to lower heart rate, reduce blood pressure, and increase parasympathetic tone within minutes. This practice, sometimes called extended exhalation breathing, does not require training or experience. It simply requires the intention to breathe out more fully than you breathe in. The body responds immediately. It does not take long to begin letting go. Once you show the nervous system the direction you want to go, temperature plays a profound and underappreciated role in the transition to sleep. Core body temperature must drop by approximately 1 to 2 degrees Fahrenheit for sleep to begin and be maintained. This is why the body redistributes blood to the hands and feet as sleep approaches, releasing heat through the skin's surface in a process called vasodilation. feeling warm at the periphery, the soft warmth of hands and feet. While the core cools is one of the body's most reliable signs that letting go has begun. The sensation of spreading warmth that many people notice as they drift toward sleep is not imagination. It is thermoregulation. It is the body relaxing its grip on wakefulness. The transition between wakefulness and sleep is not a single moment. It is a gradual dissolution that researchers track across distinct stages of electrical brain activity. In the hypnagogic state, the borderland between waking and sleeping, brain activity shifts from the fast, irregular rhythms of alert consciousness to the slower, smoother waves of relaxed awareness, and then into the even slower waves that mark the onset of sleep. During this transition, many people experience brief, vivid images or sensations arising without warning. These are not disturbances. They are the brain loosening its grip on the waking narrative. The first, tentative signs of letting go at the deepest level. Alpha waves, oscillating at between 8 and 12 cycles per second, are associated with a state of calm, unfocused awareness. They are most prominent when the eyes are closed and the mind is at rest, but not yet asleep. Researchers have found that individuals who produce more alpha wave activity tend to experience lower levels of anxiety, greater cognitive flexibility, and more effective emotional regulation. Alpha activity is also associated with the kind of relaxed, wandering thought that precedes creative insight. When you allow yourself to simply lie still and let thoughts pass without pursuing them, you are likely generating exactly this kind of brainwave. The mind at rest is not idle. It is drifting in a way that waking effort rarely allows. Progressive muscle relaxation is a technique developed by physician Edmund Jacobson in the early 20th century. Based on the observation that mental tension is always accompanied by muscular tension, and that releasing one tends to release the other, the technique involves deliberately tensing specific muscle groups and then releasing them, moving systematically through the body, from feet to face. Decades of clinical research have confirmed its effectiveness for reducing anxiety, lowering blood pressure, improving sleep quality, and reducing the physiological markers of stress. What Jacobson understood intuitively, neuroscience has since confirmed. The body and the mind are not separate systems learning two different lessons. They are one system, learning one thing together. The skin is the body's largest organ, and it is exquisitely sensitive to the state of the nervous system. When the sympathetic system activates under stress, sweat gland activity increases, skin conductance rises, and blood is redirected away from the skin toward the muscles. When the parasympathetic system takes over, this process reverses. Skin conductance drops, blood flow returns to the surface, and the skin warms and softens. This is why a person who has let go of tension will often feel and look visibly different from a person who is still holding on. The face softens, the color changes, the entire surface of the body relaxes and opens, like a flower that has stopped bracing for frost. The digestive system has its own nervous system, a mesh of over 100 million neurons lining the gastrointestinal tract, sometimes called the enteric nervous system. This system communicates with the central brain, primarily through the vagus nerve, and it is exquisitely sensitive to psychological state. Chronic stress suppresses digestive function. The gut slows, contracts, and becomes less efficient. When the parasympathetic system activates, when letting go truly begins, digestive function resumes, the stomach churns, the intestines resume their rhythmic movement. Even the microbiome, the vast community of microorganisms inhabiting the gut, responds to the state of the nervous system in ways that researchers are actively mapping. And so, in these first 25 facts, a picture is already forming. Letting go is not an abstract emotional gesture. It is a full-body biological event involving the nervous system, the brain's architecture, the heart's rhythm, the muscles, the breath, the skin, the gut. Every system in the body has a letting go mode. Every system waits, quietly, for the signal that it is safe to use it. The question is not whether the body knows how to release. It always has. The question has always been, what prevents the signal from arriving? And what happens, quietly and beautifully, when it finally does? Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain sorting the day's impressions, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. Your nervous system is already moving in the direction of release. You do not need to push it. It knows the way. Simply notice the quiet shift already happening inside you. You are already letting go. Now we continue. The parasympathetic state has a sound. Researchers studying heart function under different autonomic conditions have found that the interval between heartbeats becomes more even, more rhythmically stable. When the body enters rest, the heart does not simply slow down. It becomes more orderly, more harmonious. Cardiologists sometimes describe this evening out as cardiac coherence, a term that captures the way the heart's rhythm aligns with the breath's rhythm when tension is released. The heart and the lungs, in a state of letting go, begin to breathe together. This coherence is measurable, consistent, and, in the subjective experience of the person feeling it, often described as a sense of deep rightness, as if the body has returned to something it always knew. GABA, gamma-aminobutyric acid, is the brain's primary inhibitory neurotransmitter, where glutamate accelerates neural activity. GABA slows it, quiets it, creates the conditions for rest and sleep. Many widely studied sleep aids and anti-anxiety medications work by enhancing GABA activity, but the brain produces GABA naturally and produces it more abundantly under conditions of relaxation, gentle movement, and psychological safety. The process of letting go, releasing the need to monitor, plan, and defend, increases the brain's own natural sedation. The chemistry of rest is already inside you. It requires only the conditions to express itself. Oxytocin is often called the bonding hormone, associated primarily with social connection and trust. But its role in the body's relaxation response is equally significant and less often discussed. Oxytocin directly inhibits the stress response, suppressing cortisol, reducing the amygdala's alerting signals, and promoting the shift toward parasympathetic dominance. It is released during positive social contact, during moments of genuine safety, and, research suggests, during the experience of being deeply heard or understood. The felt sense of being safe enough to let go is not purely psychological. It is oxytocin doing exactly what it was designed to do. The concept of psychological safety, the subjective sense that one is not at risk, has become one of the most studied constructs in clinical and organizational psychology over the past 2 decades. Research consistently shows that psychological safety is a prerequisite for the kind of cognitive flexibility, creativity, and emotional openness associated with well-being. It is also, as sleep researchers have noted, a prerequisite for deep sleep. The brain does not enter its most restorative stages in environments it perceives as uncertain or unresolved. Letting go, in its deepest form, requires the felt sense of safety. The nervous system must believe, in whatever quiet way it believes things, that the concern has passed. Norepinephrine is a neurotransmitter and hormone that plays a central role in the alerting response, heightening awareness, narrowing attention, accelerating heart rate, and suppressing all biological functions deemed unnecessary during a demanding moment. Crucially, norepinephrine levels in the locus coeruleus, the brain's primary norepinephrine-producing region, drop dramatically during deep sleep and drop even further during REM sleep. This chemical quieting is not merely a side effect of sleep. It is one of the reasons sleep is restorative. The brain, during sleep, bathes itself in dramatically reduced norepinephrine. What that feels like, experienced from the inside, is the sensation of finally, fully letting go. The body's stress response system, the hypothalamic pituitary adrenal axis, or HPA axis, operates on a feedback loop. The hypothalamus signals the pituitary gland, which signals the adrenal glands to release cortisol. But cortisol, once released, feeds back to the hypothalamus and pituitary to signal that the response has been activated. Under normal conditions, this feedback dampens the response over time. The system hears itself and quiets. Under conditions of chronic tension, this feedback loop can lose its sensitivity, and the system continues responding past the point of need. Learning to let go, regularly and deliberately, is in part a process of restoring the system's ability to hear its own signal of completion. Sleep moves through repeating cycles of approximately 90 minutes each, and most adults move through 4 to 5 of these cycles per night. Each cycle contains stages of light sleep, deep, slow-wave sleep, and REM sleep. The first half of the night is dominated by slow-wave sleep, the deepest, most physically restorative stage, during which growth hormone is released. Cellular repair accelerates, and immune function strengthens. The second half of the night is dominated by REM sleep, the stage in which the brain processes emotional memories and integrates new experience. Both halves require a version of letting go. Deep sleep requires the body to release wakefulness, and REM sleep requires the brain to release the day's emotional charge. Slow-wave sleep, sometimes called deep sleep, is the stage during which the glymphatic system is most active and during which the brain produces its slowest electrical waves, delta waves, oscillating at less than 4 cycles per second. These waves sweep across the cortex in slow, rhythmic pulses, coordinating the transfer of memories from short-term storage in the hippocampus to longer-term networks in the cortex. The brain is deciding, in its own quiet language, what from today is worth keeping. And as those delta waves move through, the metabolic byproducts of a full day of thinking and feeling are gradually cleared. The deepest letting go and the deepest cleaning happen in the same moment. REM, sleep. Rapid eye movement, sleep, was first identified by researchers Eugene Aserinsky and Nathaniel Kleitman in 1953, when they noticed that the sleeping eyes of research subjects moved rapidly under closed lids during certain sleep stages, and linked these movements to dreaming. Subsequent decades of research have revealed the extraordinary complexity of what the brain does during REM. The motor cortex is largely disconnected from the muscles during this stage, a protective mechanism that prevents the body from acting out dream content. But the emotional centers of the brain are extraordinarily active. REM sleep is the night's primary emotional processing workshop. It is where the feelings of the day are sorted, metabolized, and gradually released. Some sleep researchers have described REM sleep as a form of overnight emotional processing, a nightly period during which the brain revisits emotionally charged memories in a neurochemical environment dramatically different from wakefulness. During REM, norepinephrine, the primary alerting neurochemical, is almost entirely absent. The emotional memories are replayed without the chemical signature of urgency. Over-repeated REM cycles. This process appears to reduce the raw intensity of the feeling associated with difficult memories, while leaving the factual content intact. Sleep does not erase what happened. It softens the ache of it. Night after night, it does this quiet work of release. The emotional memories most likely to benefit from this overnight processing are the ones we have been unable to fully release during the day. Research on sleep and emotional regulation has found that people who are sleep deprived show dramatically elevated responses to emotionally difficult stimuli. The same stimuli that, following adequate sleep, produce a much more measured response. In a very real sense, a night of good sleep is the biology of letting go. The events are the same. The emotional weight attached to them changes while you sleep. What felt unbearable in the evening can feel, by morning, simply like something that happened. Emotions that are suppressed, held in, controlled, not expressed, do not disappear. Research in emotion psychology has consistently found that emotional suppression tends to increase physiological arousal rather than decrease it. The body continues generating the internal experience of the emotion, even when the external expression is blocked. This creates a kind of internal tension that is metabolically expensive and cognitively draining. Letting go, in the emotional sense, does not mean not feeling. It means allowing the feeling to move through rather than holding it in place. The body is built to process emotion, not archive it indefinitely. One of the more quietly useful findings in affect science is the concept of emotional granularity, the degree to which a person can distinguish between different emotional states. Research by psychologist Lisa Feldman Barrett and colleagues has found that people with high emotional granularity, who can distinguish between feeling frustrated, disappointed, and hurt, for instance, show better emotional regulation, lower rates of depression and anxiety, and recover more readily from difficult experiences. The precision of emotional language appears to improve the brain's ability to process and release what it is feeling. Naming what you feel, with some care and specificity, helps the nervous system file it away. Not naming it keeps it circulating. The body's connective tissue, the fascia, is a continuous web of collagen-rich tissue that surrounds and connects every muscle, organ, nerve, and bone. It is not inert scaffolding. Fascia contains sensory nerves that respond to physical pressure and position, and it appears to carry its own form of contractile capacity. Research in somatics and fascial science has suggested that habitual psychological tension is associated with increased fascial holding, and that practices involving slow, sustained physical release can have measurable effects on psychological state. The body stores experience in its own architecture, and it releases experience there too, given the time and the permission. Halfway through the first arc of our journey tonight, a pattern has emerged. Letting go is not one thing. It is dozens of biological processes: neurological, hormonal, respiratory, muscular, fascial, metabolic, all oriented in the same direction, toward homeostasis, toward balance, toward the state that the body recognizes as its natural ground. The mechanisms of tension are remarkable in their sophistication, but the mechanisms of release are equally sophisticated, equally ancient, and equally trustworthy. Your body has been practicing letting go every night since you were born. Tonight is simply another practice. You are still here, still listening, perhaps still awake, perhaps drifting somewhere in between. Take a slow breath. Notice how your chest feels just a little less full than it did at the beginning. We are tracing the science of release together. You and I, and everyone listening quietly tonight in their own dark rooms. There is no hurry, no destination, just the gentle current of these facts, carrying us forward. Let's continue. The immune system and the stress response are in constant conversation. Under acute stress, certain immune functions are temporarily altered. The body prepares for potential physical challenge. But under chronic stress, prolonged cortisol elevation suppresses immune function, reducing the activity of natural killer cells, T lymphocyte, and other agents critical for disease surveillance and cellular repair. The moments of genuine letting go, sustained relaxation, restorative sleep, the parasympathetic state, are the moments during which the immune system recovers its full functioning. Rest is not separate from health. It is the condition under which health is maintained. Telomeres are the protective structures at the ends of chromosomes, sometimes compared to the small caps at the tips of shoelaces, preventing the genetic material from fraying. Each time a cell divides, telomeres shorten slightly. When they become too short, the cell can no longer divide effectively. Chronic psychological stress has been associated with accelerated telomere shortening, meaning that the cumulative physiological cost of not being able to let go may be reflected, literally, in the biology of our cells. Research linking chronic stress to telomere length has come from multiple labs, including work by Nobel laureate Elizabeth Blackburn and psychologist Elissa Epel. Whether mindfulness-based practices directly preserve telomere length remains an active area of investigation, with some studies showing promising associations. The broader finding that chronic holding has consequences at the chromosomal level is well established. The heart generates the largest electromagnetic field in the body, a field that extends beyond the skin and can be measured using sensitive instruments. When the heart is in a state of coherence, the rhythmic harmony associated with letting go and genuine calm, its electromagnetic output becomes more ordered, more sinusoidal. This shift from irregular to coherent cardiac rhythm is measurable and reproducible, and it is associated with reduced physiological markers of stress. Whether this field interacts meaningfully with the physiology of those nearby remains an open and intriguing question in psychophysiology research, one worth sitting with, even without a definitive answer. What is certain is that the heart, in a state of letting go, speaks a different language than the heart held tight. Self-compassion, the practice of treating oneself with the same kindness one would offer a good friend, has emerged as one of the most empirically robust predictors of psychological well-being in the past 2 decades of clinical research. Psychologist Kristin Neff, who developed the primary measurement scale for self-compassion, has found that self-compassion is more strongly associated with resilience, emotional stability, and the ability to release after difficulty than self-esteem. Self-esteem depends on performance and comparison. Self-compassion does not. It is available regardless of outcome, and it appears to be, neurologically, one of the most efficient routes to parasympathetic activation that psychology has found. The insula, a region of the brain tucked inside the lateral sulcus, folded beneath the temporal and frontal lobes, plays a central role in interoception, emotional awareness, and the integration of bodily and emotional experience. Research using functional neuroimaging has found that the insula is consistently active during states of emotional release, particularly during moments of compassion, awe, and the letting go of self-focused rumination. It is, in a sense, the region that helps the brain know what the body is feeling, and helps the body know that those feelings have been acknowledged. Letting go may require, among other things, simply being witnessed by one's own nervous system. Rumination, the repetitive, passive dwelling on distressing feelings and their causes, is one of the most reliable cognitive patterns associated with depression and anxiety. It is also one of the clearest descriptions, in psychological terms, of the opposite of letting go. Research has found that rumination activates the amygdala, sustains cortisol elevation, disrupts sleep, and consumes cognitive resources that would otherwise be available for adaptive processing. The content of rumination is rarely new. The same thoughts circle because the brain is attempting to process something it has not yet been given space to complete. Letting go does not always mean stopping the thoughts. It sometimes means giving them enough stillness that they no longer need to repeat. The brain's resting state network, the default mode network, includes regions involved in self-referential thought, memory, and the generation of personal narrative. When this network is healthy and well-regulated, it allows the mind to wander productively, integrating experiences, generating insight, and resting in a kind of open, unclenched awareness. When it is pulled into cycles of worry, the same circuits can become the architecture of rumination. The difference between healthy rest and anxious repetition may be, in part, a matter of whether the narrative self is holding on or letting go, whether the story the mind is telling has room to end. There is a concept in acceptance-based psychology called experiential avoidance, the tendency to resist, suppress, or escape internal experiences that feel uncomfortable. Research has found that experiential avoidance is strongly associated with anxiety, depression, chronic pain, and insomnia. The attempt to not feel something keeps the nervous system engaged with the very thing it is trying to avoid. Acceptance-based therapies, which include acceptance and commitment therapy and mindfulness-based cognitive therapy, work in part by encouraging the opposite, allowing the experience to be present without fighting it. Counterintuitively, this tends to reduce its intensity and duration far more effectively than resistance does. Sleep onset difficulty. The trouble of falling asleep despite genuine fatigue is associated in research with heightened cortical arousal and what sleep scientists call sleep effort, the vigilant attempt to make sleep happen. The harder a person tries to sleep, the more the monitoring mind remains active, scanning for evidence of failure, letting go of the effort to sleep, releasing the goal, allowing whatever state the body is in without judgment, has been found to be significantly more effective at producing sleep onset than trying harder. The body falls asleep more readily when the mind stops insisting on it. Rest arrives in the space that effort vacates. Halfway through our journey tonight, the answer to the question we began with is taking shape when you finally let go. Truly, biologically let go. Your cortisol drops. Your heart steadies. Your muscles release. Your breath deepens. Your immune system resumes its work. Your brain begins its nightly cleaning. Your emotional memories begin their overnight processing. And your cells are protected from the accelerated wear of chronic holding. Letting go is not surrender. It is not weakness, or passivity, or giving up. It is the most profoundly restorative thing a human body knows how to do, and it is waiting for you tonight, as it waits every night, patiently, without judgment, with everything already prepared. Let each breath guide you to realize, time is yours tonight, a separate stream that only you are living. While the world outside continues its turning, this moment, this breath, this heartbeat, this quiet belongs entirely to you. Every muscle you carry, every thought still circling, every feeling still unresolved. You do not need to resolve it before you sleep. Everything that needs to happen will happen. The body knows the sequence. Your only task is to allow the next breath. And we continue drifting. Touch is one of the most direct pathways to the parasympathetic state. The skin contains a specialized class of nerve fibers, see tactile afferents, that responds specifically to gentle, slow contact and sends signals directly to regions of the brain associated with social bonding and emotional regulation. These fibers respond most readily to touch at speeds of roughly 1 to 10 centimeters per second, approximately the pace of a caring caress. Research has found that gentle self-touch, including placing a hand over the heart or on the abdomen, activates similar circuits. The nervous system does not always require another person to feel held. The body can remind itself of safety through its own quiet gestures. The experience of awe, the response to something vast, beautiful, or beyond the ordinary, has been found in research to reliably shift the nervous system toward a calm, pro-social state. Psychologists Dacher Keltner and Jonathan Haidt have described awe as an emotion characterized by perceived vastness, and the sense that existing mental frameworks may be insufficient for what is being encountered. Research has found that awe reduces self-focused thinking, lowers certain inflammatory markers in the blood, and increases feelings of connection. In its quietest forms, the sight of a night sky, the recognition of something much larger than oneself. Awe is a gentle form of letting go of the self's ordinary concerns. Color and environment interact with the nervous system in ways that researchers have documented across multiple contexts. Environments with softer, cooler visual tones tend to produce lower heart rates and reduced physiological arousal compared to environments dominated by warmer, more activating colors. The nervous system may still carry ancient associations. Open sky, wide water, that certain visual environments quietly invoke. Whatever the mechanism, the body responds to its surroundings. And darkness, the absence of color, may be the most calming environment of all. The one in which everything that has been stimulating the visual system is finally, gently, allowed to rest. Time spent in natural environments, or even viewing images of nature, has been found in a growing body of research to reduce stress biomarkers including cortisol, blood pressure, and sympathetic nervous system activity. Attention restoration theory, developed by Rachel and Stephen Kaplan, proposes that natural environments restore directed attention by providing a mode of engagement they call fascination. Effortless, gentle noticing that does not deplete cognitive resources. The mind, surrounded by nature, does not need to try. It drifts, it rests, it lets go without deciding to. The body seems to remember, in the presence of the natural world, that it was always part of something larger and quieter than the day's demands. The gut microbiome, the vast community of bacteria, fungi, and other microorganisms inhabiting the gastrointestinal tract, produces a range of neuroactive compounds, including serotonin, GABA, and short-chain fatty acids that influence brain function and mood. Research in the gut-brain axis has found bidirectional communication between the microbiome and the central nervous system via the vagus nerve, the immune system, and the enteric nervous system. Chronic stress alters the composition of the microbiome in ways that may perpetuate the stress response. A body that is learning to let go, that is resting and activating its parasympathetic system, creates conditions in which the gut microbiome can also, in its own slow way, settle. The practice of gratitude has been studied extensively in positive psychology research, and the findings are remarkably consistent. Regular gratitude practice, the deliberate noticing of what is present and good, reduces anxiety, improves sleep quality, lowers blood pressure, and increases feelings of social connection. Neuroimaging studies have found that gratitude activates regions of the brain associated with positive affect and moral cognition. But there is something specific to letting go in gratitude. It shifts attention from what is absent or unresolved, the mind's habitual preoccupation, toward what is already here. It is, in a small and gentle way, the act of releasing the need for things to be different from what they are. The basal ganglia, a group of structures deep in the brain associated with habit formation, movement, and the selection of actions, play a role in what neuroscientists sometimes call behavioral gating, the process by which the brain decides which responses to allow and which to hold in check. During the transition to sleep, basal ganglia activity shifts as the need to act gives way to the permission to rest. The body's habitual readiness begins, gradually, to stand down, what we call the effort to stay awake. The grip of wakefulness loosens not through force, but through a quiet reconfiguration of these deep structures as they recognize that the time for action has passed. Music has been used as a sleep aid across cultures for millennia, and its effectiveness is now well supported by research. Studies have found that listening to slow, predictable music, with a tempo of approximately 60 to 80 beats per minute, before and during sleep onset, reduces cortisol, lowers heart rate, increases parasympathetic tone, and improves subjective sleep quality. The rhythmic predictability of music appears to entrain the brain's own oscillations, gently drawing neural activity towards slower frequencies. The brain, hearing a steady rhythm, tends to synchronize with it. Music does not lull the nervous system to sleep by accident. It offers the body a pace to follow, and the body, gratefully, follows. Research has found that mindfulness meditation practice is associated with changes in how the brain responds to emotionally activating stimuli. A landmark study by Sarah Lazar and colleagues at Massachusetts General Hospital, using structural neuroimaging, found increased cortical thickness in regions associated with attention and interoception in long-term meditators. More recent research has explored whether shorter interventions produce similar effects, with some studies finding reduced reactivity and improved emotional regulation after programs as brief as 8 weeks. The results vary across studies, and longer practice appears to produce more consistent change. The brain is not fixed. Its response to the world, including its tendency to hold tension long after the need has passed, can be gently and durably shifted. Yawning is associated with thermoregulatory function, helping cool the brain, and appears at the boundaries between neural states. It increases at sleep onset and upon waking, those moments when one state is dissolving into another. It is contagious across social groups, including across species, suggesting a communicative or synchronizing function. When you yawn right now, if you do, it is your nervous system announcing quietly that a transition is already underway. The body does not wait for permission to begin letting go. It begins the moment the conditions are present. Sometimes a yawn is the first sign that they are. The body's natural pain modulation system, the endogenous opioid system, is activated during states of deep relaxation, sustained calm, and restorative sleep. Endorphins and related compounds bind to opioid receptors throughout the brain and body, reducing the perception of discomfort and generating a sense of warmth and well-being. This contributes to the characteristic feelings of deep physical comfort associated with the moments just before sleep. The heavy, warm, loose sensation that many people describe as the body finally giving itself permission to rest. The body produces its own comfort. The conditions for its release are already present in the simple act of lying still and allowing the day to end. Research into the neuroscience of forgiveness, a specific and complex form of letting go, has found that the genuine release of a grievance produces measurable reductions in cardiovascular reactivity, cortisol output, and sympathetic nervous system activity. Neuroimaging studies have found that forgiveness activates regions of the prefrontal cortex associated with reasoning and emotional regulation, and reduces activity in regions associated with vigilance and emotional alarm. These are not small effects. The biology of forgiveness overlaps substantially with the biology of relaxation. The body, it appears, cannot entirely distinguish between releasing a grievance and releasing a muscle. Both are acts of the same quiet unwinding. The concept of radical acceptance, developed in clinical psychology by Marsha Linehan as a core component of dialectical behavior therapy, describes the act of fully acknowledging reality as it is, without fighting, resisting, or demanding that it be otherwise. Research on acceptance-based interventions has found that radical acceptance reduces emotional suffering not by solving the problem, but by removing the additional layer of pain created by the resistance to it. The original difficulty remains, but the amplification created by the fight with it dissolves. This is, perhaps, one of the most precise psychological descriptions of what letting go actually means. Not the removal of what is hard, but the removal of the war with it. The brain naturally oscillates between two broad patterns of activity: focused engagement during demanding tasks, and the diffuse, inward activity of the default mode network during rest. These two patterns exist in a kind of balance. When one increases, the other tends to decrease. Healthy functioning depends on the ability to move freely between them. Chronic difficulty releasing external demands. The inability to allow the default mode its natural period of activation may over time impair both the quality of rest and the quality of focused attention. The brain needs its wandering time as much as its working time. Letting go of the task is not a failure of productivity. It is what makes tomorrow's attention possible. We are past the halfway point of our journey tonight, and the picture has grown richer and more specific. Letting go involves not just the nervous system and the brain's architecture, but the immune system, the microbiome, the fascia, the telomeres, the rhythm of the heart, the chemistry of forgiveness, the neuroscience of acceptance, and the brain's need for its own quiet, unclaimed time. Every one of these systems has a state it returns to when safety is felt and resistance is released. That state is not dormancy. It is activity of a different kind, turned inward, turned toward repair, turned toward the deep and patient work of becoming whole again. Melatonin, the hormone synthesized by the pineal gland from serotonin as darkness falls, rises gradually in the hours after sunset, peaking in the middle of the night and declining toward dawn. It does not cause sleep directly. It signals the brain that it is time to shift into sleep mode, the time of night marker, not a sedative. The pineal gland's sensitivity to light means that even brief exposure to bright light, particularly blue spectrum light, can suppress melatonin and delay the body's natural letting go signal. In the quiet dark where you are now, your melatonin is already rising, the body already beginning the chemistry of release, without your asking. Psychological flexibility, the ability to adapt behavior in response to changing circumstances while remaining connected to what matters, has been identified in extensive research as one of the most robust predictors of mental health across clinical populations. Its opposite, psychological inflexibility, rigid patterns, avoidance of difficult internal experiences, domination by past or future, is strongly associated with depression, anxiety, and chronic stress. Learning to let go, in this framework, is not abandonment of values or purpose. It is the development of a more fluid relationship with experience. The capacity to hold what matters lightly enough that it can be carried without exhausting the carrier. The practice of body scan meditation. The systematic, non-judgmental attention to different regions of the body, typically moving from the feet upward, has been studied extensively in mindfulness-based stress reduction programs developed by John Kabat-Zinn at the University of Massachusetts Medical School. Research has found consistent effects on sleep quality, pain perception, anxiety, and cortisol levels following sustained practice. What the body scan accomplishes, at its simplest, is bringing the mind's attention to the places in the body where holding on is happening, without asking anything of those places except to be noticed. Often, that noticing alone is sufficient to begin the release. Serotonin plays a central role in mood regulation, appetite, digestion, and the preparation for sleep. During waking, serotonin-producing neurons in the raphe nuclei are most active. During NREM sleep, their activity decreases. During REM sleep, they fall almost silent. This progressive quieting of the serotonin system through the night is part of the neural signature of letting go. A gradual dimming of the daytime chemistry of directed activity. The body's chemistry does not switch abruptly between states. It transitions, slowly and continuously, like light changing across an afternoon. Each stage of the night is a deeper version of the release that began the moment you lay down. Dreams during REM sleep are not random noise generated by a disengaged brain. Research using neuroimaging and the systematic study of dream content has found that dreams tend to recombine elements of recent and more distant experience in ways that serve memory consolidation and creative integration. Studies have found that REM sleep improves performance on creative insight tasks, problems that require seeing a new relationship between known elements. The dreaming brain is a brain practicing letting go of the fixed categories of waking thought, mixing and recombining experience without the constraints of what is literally possible. Creativity, at its neural root, may be a form of the mind releasing its grip on what it already knows. The experience of being deeply moved by music, by beauty, by a meaningful moment, is associated with a characteristic physiological response researchers call frisson, a wave of sensation moving across the skin, often accompanied by a feeling of expansion in the chest. Research has found that frisson is associated with dopamine release in reward-related regions of the brain. The autonomic response is nuanced. The body experiences a kind of pleasurable activation at the boundary between heightened sensation and deep release. It is, perhaps, what it feels like when the nervous system is moved by something larger than itself. A brief, beautiful confusion of wonder and surrender. Sleep inertia, the grogginess felt immediately upon waking, is a period of incomplete transition between sleep and wakefulness, during which certain brain regions remain in a sleep-like state, while others have returned to waking consciousness. Research has found that sleep inertia is stronger following abrupt awakening from deep sleep stages and weaker following awakening from lighter stages near the end of a natural cycle. The body, allowed to finish its letting go, to complete the full arc of the night's work, wakes more easily, more gently, more ready to begin again. The quality of the morning is often a reflection of the completeness of the night's release. The process of memory consolidation during sleep involves the quiet reactivation of neural patterns laid down during waking experience, an unconscious rehearsal of what was learned, seen, or felt during the day. Research has found that this reactivation occurs primarily during slow-wave sleep for procedural and factual memories, and during REM sleep for emotional and associative memories. The brain, during sleep, is actively sorting and selecting, deciding what deserves to be kept, what can be released, and what connections are worth making. Sleep is the night editor of the day's manuscript, and letting go is what allows the editor to work. The hypnic jerk, the sudden involuntary muscle contraction that can briefly startle a person just as they are drifting off, is a normal and benign neurological event related to the transition between wakefulness and sleep. As the motor cortex begins to disengage from voluntary muscle control, a brief burst of activity can produce the sudden contraction. Some researchers have proposed an evolutionary origin. In early hominids, the relaxation of postural muscles during sleep in trees may have been interpreted by the brain as falling, triggering a brief corrective response. Even the body's letting go has its own moment of startled hesitation. One last check before the long, quiet surrender. 3/4 of the way through our journey tonight, the science of letting go has revealed something quietly profound. The body is not designed to hold on indefinitely. Every system, from the molecular level of cortisol and telomeres, to the cellular level of the glymphatic flush, to the tissue level of fascial release, to the organ level of the heart's coherence, to the neural level of the amygdala's quieting, to the psychological level of acceptance and self-compassion. Every system has a release state that it is oriented toward. The body wants to let go. It has always wanted to let go. What we call rest, what we call sleep, what we call peace. These are not things we achieve. They are things we allow. You might be feeling tired now. That is perfectly fine. Breathe slowly. Feel the cycles. Your heart has been beating since before you could remember, finding its rhythm without instruction. Your breath rises and falls in its own ancient time. Your cells have been repairing themselves in darkness every night of your life, without needing to be asked. You are part of a system that knows how to care for itself. You don't need to hold on to anything. Let everything unfold in its perfect, patient order, like a body slowly releasing into the rest it has been earning all day. We're almost there now. When you let go, your blood pressure drops. The smooth muscle cells lining the arteries relax. Blood flows more easily. The heart works less hard. The whole system, built for a moment of alertness that has now passed, finally stands down. Your body temperature at the surface begins to rise as you release. Heat moves outward to the hands, the feet, the face. The core cools. This is the body preparing for deep sleep, redistributing warmth to the edges, making space at the center for the night's quiet work. The lateral prefrontal cortex, the region associated with logical control and planning, grows quieter as sleep approaches. Its grip on the mind loosens. Thoughts become less linear, less deliberate. Images arise without narrative. This is not confusion. It is the beginning of a different kind of knowing. Your immune system, freed from the suppression of chronic stress hormones, begins its nightly work. Natural killer cells increase their activity. Cytokines coordinate the repair of small cellular injuries accumulated throughout the day. The body heals most efficiently in the quiet. It has always known this. The lymphatic system quietly processes the day's immune challenges. Unlike the circulatory system, the lymphatic system has no pump. It moves by the rhythm of your breath and the gentle compression of your muscles at rest. Each slow breath moves lymph. Each relaxed exhale carries something gently through. Growth hormone, the primary hormone of cellular repair and tissue regeneration, is released in its largest nightly pulse during the first hours of deep sleep. It repairs muscle, supports bone renewal, and contributes to the restoration of skin and tissue. It is released most abundantly when the body is most deeply at rest. The deepest letting go is the deepest repair. The hippocampus, the brain's primary structure for the formation of new memories, replays the day's experiences in compressed sequences during slow-wave sleep, gradually transferring information to longer-term storage across the cortex. As you release the day, the brain is quietly deciding what to keep. Not everything needs to be held. Some things are meant to pass through and let go. The body's core temperature reaches its lowest point in the early morning hours. By this time, the night's deepest physical repair has largely been accomplished. The system has been cleaned, consolidated, and restored. The body rests at its lowest, quietly preparing to rise again toward the light. Your breathing, by now, is slower than it was an hour ago. Each exhale a little longer, a little softer. This is not effort. This is the respiratory system finding its own natural pace, the pace it has always known, and returns to every night, without instruction. The brain's electrical activity during deep sleep produces slow waves that travel across the entire cortex in coordinated sweeps, front to back, like gentle tides. These waves are not random. They are organized, rhythmic, purposeful. The deepest brain is doing the most coherent thing it does in any 24 hours. Somewhere in the night, the brain shifts from deep sleep back toward REM. The eyes begin their quiet movement beneath closed lids. A different kind of processing begins. Softer, more associative, more willing to let things be strange and beautiful. The night is long and the cycles continue. Patient and unhurried. Every cell in your body contains mitochondria, the ancient organelles that produce the energy your cells need to live. During sleep, mitochondrial repair processes accelerate. Damaged mitochondria are cleared away. New ones are generated. Even at the most fundamental level of the cell, rest is renewal. Letting go reaches all the way down. The vagus nerve continues its quiet work throughout the night, carrying the body's letting go signal through the chest and into the abdomen, coordinating the heart, the lungs, the gut, and the liver as they each settle into their restorative rhythms. The body's internal wisdom does not rest. Only the body's effortful trying does. Researchers studying the phenomenon of insight, the felt arrival of a solution or understanding, have found that sleep, particularly REM sleep, significantly increases the likelihood of insight following a difficult problem. The brain, freed from the fixed pathways of deliberate thought, finds connections that were invisible before. Sometimes, the answer arrives not by thinking harder, but by releasing the thinking entirely, What the day could not solve, the night quietly rearranges. The body is more than 80% water. During sleep, fluid dynamics shift. Cerebrospinal fluid flows more freely through the lymphatic channels, and the tissues of the body redistribute their fluid in the context of deep rest. You are, in sleep, a moving system, never static, never truly still, just moving in a different direction than the day allows. The body at rest is not the body stopped. It is the body flowing inward. The sense of smell is the only sense whose signals travel directly to the limbic system, the brain's emotional center, without first passing through the thalamus. This is why certain scents can evoke a shift in emotional state almost instantly. The scent of something familiar and safe, a particular wood, a rain-soaked evening, something from long ago, can move the nervous system toward the parasympathetic state more quickly than almost any other sensory input. The body knows safety through the nose, sometimes before the mind has named what it recognized. The sleeping brain produces its own chemistry, a rich, shifting environment of neurotransmitters and hormones that researchers are only beginning to fully map. Each night, without instruction, the brain engineers its own conditions for restoration. It adjusts its ratios of alerting and calming compounds, shifts the balance between activity and stillness, and creates, through its own biological intelligence, the precise internal environment that makes repair possible. You do not need to understand all of it. You only need to allow it to happen. The prefrontal cortex's steadying influence over the amygdala's alert signals is restored by sleep. Studies comparing emotional reactivity before and after a night of sleep consistently find that adequate rest restores the prefrontal cortex's capacity for gentle regulation. What felt overwhelming the night before often feels more manageable in the morning. Not because the facts have changed, because the brain has rested enough to hold them from a greater distance. With a steadier hand, the circadian rhythm that governs the sleep-wake cycle also governs a vast range of other biological processes, including hormone secretion, immune function, cell division, and gene expression. Hundreds of genes in every tissue of the body are expressed in circadian patterns, turning on and off in coordination with the light-dark cycle. The body has a time for everything, a time for alertness, and a time for rest, a time for effort, and a time for release. Tonight is the time the body has been orienting toward all day. Some researchers have observed, in studies of the hypnagogic transition, the borderland between waking and sleep, brief bursts of high-frequency brain activity just before consciousness dissolves, as if the mind, in its final waking moment, gathers itself one last time. What this represents in neural terms continues to be studied, but the experience of it, that last flicker before the dark, is something most people have felt, even if they could not name it. And then, the deepest answer to everything we have explored tonight arrives not in thought, but in the body's own wordless knowledge. Every system that has been waiting, the lymphatic clearance, the immune patrol, the emotional processing, the cellular repair, was always ready. They needed only the silence that letting go creates. You have been carrying the capacity for all of this, every single day. Tonight, you are finally allowing it. And so, our quiet journey through the science of letting go comes gently to a close. We have traveled from the first millisecond of cortisol release when the body decides it is safe to stand down, to the final flicker of waking consciousness before sleep claims it. We wandered through the glymphatic channels, cleaning the sleeping brain, through the REM cycles, processing the day's feelings into something softer, through the cells being repaired in the deep quiet of slow-wave sleep, and through the heart finding its coherence in the stillness. Along the way, we discovered that letting go is not passive, not empty, not a loss. It is the most active and purposeful thing the body knows how to do. It is the night shift of biology, more industrious, in its own way, than anything the day demands. The science of letting go reminds us that much of the body's most important work happens in the surrender, not in the striving, not in the monitoring, not in the holding tight, but in the moment the muscles soften, the breath deepens, and the long day finally releases its claim. The body has been practicing this every night since birth. It has never forgotten how. By pausing to understand it, we come a little closer to trusting it. In these final minutes, take the deepest breath you can. As deep as possible, think about the unity of every system that has been working quietly tonight. The nerve that carries the letting go signal, the cells that repair in the darkness, the brain that processes and releases and makes space for tomorrow. You are not separate from any of this. You are the one in whom all of it is happening. Let your entire being dissolve into the soft, biological night, into the body's oldest wisdom, into the rest that has been waiting for you all day. Prepare for deep sleep. No boundaries left, only peace. If following the science of letting go helped you release something tonight, helped you feel that the body's wisdom is real and present and already working, a quiet like or subscribe could carry that same permission to someone else, lying awake right now, searching for exactly what you found here. It might be exactly what another tired mind needs tonight, to find their own way to stillness. One quiet tap, one sleepy soul at a time. But there's no need to do anything now. Nothing at all. You have traveled far tonight. Inward. Through corridors most people never pause to notice. You touched the architecture of your own biology and found it more patient, more wise, more quietly capable than the day's noise ever allows you to remember. You can allow these thoughts of letting go to fade now, like the last cortisol dissolving in a bloodstream that has finally been told. The concern has passed. The day is done, leaving only the soft, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if careful, invisible hands have taken everything you were still carrying and set it gently, respectfully, aside. If sleep comes, let it carry you the way the body's own chemistry already knows how. Not falling, not forced, simply arriving into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, to stay there, stay in the darkness that feels safe and warm. Tomorrow, your nervous system will still be listening. The body's wisdom will still be turning. But tonight belongs to stillness. Rest well, sleepy soul, and remember, the body has always known how to come home. Good night.